And I know many of you may say, well, this correlates to, 0 over 0, comma 1 over 0. Well, what is 0 over 0 then? And, it may seem like that's what it is, but that's not exactly how it is. I mean, in this setting of the projective plane, it makes sense to have 0 over 0 as long as x, y, and z are not all equal to 0. If they're all equal to 0, it makes absolutely no sense. But we can sort of work with it as long as we can figure out what it means, as long as one of them has a value of 1, or some non-zero element of a field. So you can think of 0 to 1 to 0 having just an x-coordinate of 0, so not traveling anywhere on the x-axis. And then 1 over 0 in the y direction, which means like infinity on the y direction, infinitely upward on the y-axis. So that is one point at infinity. And you might be able to guess the other so-called point at infinity. It would be infinitely far on the x direction. Because, well, clearly it's 1 over 0 as the x-coordinate, so it's infinity on the x-coordinate, and 0 on the y-coordinate. And because the projective plane is topologically a sphere, and in fact, when you get to more advanced algebraic topology, you'll find out that the sphere is a covering map for the projective plane, which is rather complicated, but hopefully we'll get to that later. But effectively what this means is that this plane wraps around, such that if you go infinitely far south, so to speak, or far, like, in the negative numbers on the y-axis, you will also reach this same point at infinity. So it wraps around like that, and the same property for in the x direction. If you go in this direction, you'll also get to infinity. So it's very interesting, and we can study different functions in the projective plane. A very common one that is studied as an exercise is the function y equals 1 over x. So in part 3 we will study a function that is defined in the projective plane. Let me know if you have any questions or comments, and thank you for watching.